ratio and proportion. So let us see our first sum today. The question is, if A upon B is equal to C upon D, then prove that 2A plus 3B into 2C minus 3D is equal to 2A minus 3B into 2C plus 3D. So we are given with a proportion A upon B is equal to C upon D. Now if we look at what is required in the proof, the coefficients of A and C, that is the numerators on left hand side and right hand side is 2, and the coefficients of B and D is 3. So we multiply the proportion on both the sides. We multiply by 2 upon 3 on both the sides. So we get 2A upon 3B is equal to 2C upon 3D. Now we use the property of Componendo and Dividendo. Using Componendo and Dividendo together, what we get is 2A plus 3B upon 2A minus 3B equals to 2C plus 3D upon 2C minus 3D. Now if we look at what is required in the proof, we just need to cross multiply the denominators in this equation. So on cross multiplying the denominators in this equation, we get 2A plus 3C, 2A plus 3B into 2C minus 3D is equal to 2C plus 3D into 2A minus 3B. Hence, our required result is obtained. Moving on to the next question, if 11a square plus 13b square upon 11c square plus 13d square is equal to 11a square minus 13b square upon 11c square minus 13d square, then prove that a, b, c, d are in proportion. Now to prove these numbers a, b, c, d are in proportion means we need to prove that a upon b is equal to c upon d. So from the given equation, if we look at the given equation, the numerators on both the sides have terms with a and b, whereas denominators have terms with c and d. So using the first property of Alternendo, that means we cross multiply one denominator and one numerator. What we get is we cross multiply these two, the denominator of left hand side and numerator of right hand side. We get 11a square plus 13b square upon 11a square minus 13b square on the left hand side. And the right hand side is 11c square plus 13d square upon 11c square minus 13d square. So now if we see that this is something similar we get when we apply Componendo and Dividendo. And in this, if we again apply Componendo and Dividendo, if we apply Componendo and Dividendo again, what we get is 11a square plus 13b square plus 11a square minus 13b square upon 11a square plus 13b square minus 11a square minus 13b square on the left hand side, and similarly on the right hand side we get 11c square plus 13d square plus 11c square minus 13d square upon 11c square plus 13d square minus 11c square minus 13d square. Now when we simplify this, we get plus 13b square and minus 13b square cancelled in the numerator, and what is left is 22a square. In the denominator, when we open the brackets, the sign inside the bracket will change, that is minus into minus will become plus. So here 11a square and minus 11a square will get cancelled, and what is left is 13 plus 13, that is 26b square. On similar calculations in the right hand side, we get 22c square upon 26d square. Now dividing this equation by 22 upon 26 on both the sides, we get this 22 and 26 cancelled out. So now what is left is we are left with a square upon b square equals to c square upon d square. And now this is just one step away from our required proof. So taking square roots on both the sides, we get a upon b is equal to c upon d, or we can say that a, b, c and d are in proportion. In the next question, it is given that x cube plus 12x upon 6x squared plus 8 is equal to y cube plus 27y upon 9y square plus 27. Then we need to find the ratio x is to y. So applying componendo and dividendo to the given equation, applying componendo and dividendo, we get x cube plus 12x plus 6x square plus 8 upon x cube plus 12x minus 6x square minus 8 equals to y cube plus 27y plus 9y square plus 27 upon y cube plus 27y minus 9y square minus 27. Now if you look at this four expressions, the number 8 and number 27, these are perfect cubes. Now this gives the hint of using the identities for cube. So if we rearrange the terms, or if we rewrite the terms as x cube, 8 can be written as 2 cube, 12x can be written as 3 into x into 2 square, and 6x square can be written as 3 into x square into 2. So this gives us the identity of a plus b the whole cube, which is a cube plus 3ab square plus 3a square b plus b cube. Similarly, in the denominator, If we see these terms, the terms are same, only the signs are different. The two signs which are different are negative 3 into x square into 2 minus 2 cube. So this becomes the identity of a minus b whole cube. So using these two identities in the left hand side, we get x plus 2 whole cube upon x minus 2 whole cube. Similarly, if we see on the right hand side, it forms the identity of y plus 3 whole cube in the numerator and y minus 3 whole cube in the denominator. Now taking cube roots on both the sides, we get x plus 2 upon x minus 2 is equal to y plus 3 upon y minus 3. Now again applying the property componendo and dividendo, we get x plus 2 plus x minus 2 upon x plus 2 minus x plus 2 equals to y plus 3 plus y minus 3 upon y plus 3 minus y plus 3. And on simplifying this, we are left with 2x upon 4 is equal to 2y upon 6. Now using first simplifying this fraction to the simplest form, we get x upon 2 and y upon 3. And now applying the property of alternendo, we get x upon y is equal to 2 upon 3. So our required answer x is to y, the ratio is 2 is to 3. Another type of questions that can come from this topic is solve the equation for the variable x. And the equation is square root of 3x plus 4 plus square root of 3x minus 5 upon square root of 3x plus 4 minus square root of 3x minus 5 equals to 9. Here 9 on the right hand side can also be written as 9 upon 1. And now applying the property of componendo and dividendo, what we get is square root of 3x plus 4 plus square root of 3x minus 5 plus square root of 3x plus 4 minus square root of 3x minus 5 upon square root of 3x plus 4 plus square root of 3x minus 5 minus square root of 3x plus 4 minus square root of 3x minus 5 is equal to 9 plus 1 upon 9 minus 1. Here the point to be remembered is the property componendo and dividendo is applied to a proportion. Means you have to apply it on both the sides of the given equation. Now on simplifying this in the numerator, square root 3x minus 5 will get cancelled, and in the denominator after opening the brackets minus minus sign will become plus, and here square root 3x plus 4 will get cancelled out. So we are left with 2 times square root of 3x plus 4 upon 2 times square root of 3x minus 5 is equal to 10 upon 8. On simplifying this, 2 will get cancelled out, and reducing the right hand side, it will be 5 upon 4. Now squaring both the sides, we get 3x plus 4 upon 3x minus 5 is equal to 25 upon 16. On cross multiplication, we get 48x plus 64 is equal to 75x minus 125. On taking the like terms, transposing 48x on right hand side and 125 on left hand side, we get 64 plus 125 equals to 75x minus 48x. So that is 189 is equal to 27x, or x is equals to 189 upon 27, that is x is equals to 7. Moving on to the last question, again it is solve for x. 1 plus x square upon 1 minus x plus x square is equal to 62 into 1 plus x upon 63 into 1 minus x. Now before applying the property here, if we see these brackets and connect it with the left hand side, we get the identity of sum or difference of two cubes. So first we cross multiply these two brackets, we get 1 minus x into 1 plus x square upon 1 plus x into 1 minus x plus x square is equal to 62 upon 63. So this is the identity of, in the numerator it is the identity of a cube minus b cube, which is a plus b into a minus b into a square plus ab plus b square, and in the denominator it is a cube plus b cube, which is a plus b into a square minus ab plus b square. So in the question, the value of a is 1 and the value of b is x. So we get 1 minus x cube upon 1 plus x cube is equal to 62 upon 63. And now we apply the property componendo and dividendo. We get 1 minus x cube plus 1 plus x cube upon 1 minus x cube minus 1 minus x cube equals to 62 plus 63 upon 62 minus 63. On simplifying, we get minus x cube plus x cube cancelled. in the numerator and in the denominator, plus 1 minus 1 cancelled. So now we have 2 upon negative 2x cube is equal to 125 upon negative 1. On reducing this to simplest form, 2 gets cancelled and minus sign gets cancelled from two denominators. We are left with 1 upon x cube equals to 125 upon 1. Or if we cross multiply, we get x cube equals to 1 upon 125, and taking cube root, we get the value of x, which is 1 upon 5.